Welcome to Cloud on Air, the live webinars from Google Cloud. We are hosting webinars every Tuesday. My name is Elias Pinto. I'm a customer engineer in New York, and today we're joined by Prabhu Palanisamy from SpringML. We will be talking about how to make your media content discoverable and engaging. For folks on the line, you can ask questions anytime on the platform, and we have Googlers on standby to answer them. So Prabhu, why don't you tell us a little bit about yourself and what you do at SpringML? Why don't you take it away?
All right, thanks Elias. Hello everyone. Thanks for the opportunity to present SpringML and some of our machine learning use cases we recently implemented for our customers. By the way of introduction, my name is Prabhu Palanisamy. I'm one of the co-founders at SpringML. I'm delighted to give an intro of SpringML and highlight some of the Google Cloud technologies from a machine learning standpoint. SpringML, we started in 2015 and specializing in data analytics and machine learning. Our two strategic partners are Google and Salesforce. We specialize in a couple of verticals, namely media, healthcare, technology, and energy. Today, we are going to focus on media and entertainment industry and showcase some of the applications in machine learning. From a capability standpoint, SpringML has deep integration and data processing experience. Coupled with machine learning and advanced data analytics makes it ideal for enterprises who have data intensive use cases. From a recognition standpoint, SpringML is one of the very few companies in the world in the Google ecosystem that has machine learning and data analytics specialization. Here I'm going to highlight a couple of vertical domains that have what I call data intensive use cases. For example, energy has a lot of exploration, GPS related use cases, healthcare on the payer side, provider side, and of course media, the discussion of the topic today, generate a vast amount of video files, audio files, and image files on a daily basis. Traditionally, implementing insights using machine learning for these large data sets has been challenging. With the introduction of Google machine learning APIs and some of the frameworks, makes it easy for us to implement such solutions to our enterprise customers in a matter of days and not months. Quick overview of SpringML and how we serve our customers. SpringML provides a combination of applications and services. Applications are lightweight frameworks that have pre-built machine learning models and associated functionalities built in. And from a services standpoint, we help customers to go through the implementation cycle all the way from strategy, integration, implementation, and continuing the virtuous cycle. So what we believe at SpringML is a journey. At customers where we take them on a journey of implementation and making them successful in machine learning and data analytics. Again, to just quickly summarize from a SpringML standpoint, SpringML is one of the premier partners in the Google Cloud ecosystem that have specialization in data analytics and machine learning. Now to come to the topic of the discussion today, if we look at it, digital assets grow on a daily basis. These are some of the stats that I pulled from Gartner Research and other agencies where data that is generated today, 90% of those data sets are now is in a form of an image, audio file, or a video file. Chief scientist Fifi Lay at Google aptly puts it as dark matter of the web. These are assets that are under analyzed. Now, with the use of Google machine learning APIs, I'm going to go through a set of use cases and demos that will highlight the implementation of these technologies and how customers can take advantage and build new source of revenue using these media assets. So let's break it down. When I mean by digital assets or a media asset, it could be one or more or combination of the above here. It could be an audio file, it could be a video file, it could be an image file. And customers traditionally look for type of analysis, for example, a video file, customers look to do some transcription associated with it, find objects of interest, location, a person, or if there is an audio attached to the video, what type of sentiment or what the conversation is around. As you may imagine here, there are multiple levels of analysis here. For example, if we take a video file, how we can break it down into frames, analyze the frames, find the insights from the frames, and in parallel do transcription, find the text, the language associated with it, and even find objects of interest, or even perform optical character recognition or OCR. For example, if there is a logo present in the video, what type of logo can I recognize them? To now walk through these use cases, hopefully I perked your interest to showcase what type of media files and how to analyze them. Let me walk through one by one. For example, image files. Customers are interested in finding what type of image file it is and who is there in the image. Can I read that image to find insights from the asset? Same thing with video files. If I have long running videos and I need to find insights quickly, how can I process them and avoid human labor? The demo that I'm going to show today is going to be a long running video. Today, if we were to process them, it requires a lot of human labor. With the use of machine learning APIs and custom TensorFlow models and the Google Cloud technologies, these processes cut down the implementation and the processing time. Similarly, on the audio side, how do we do text transcription, language translation to variety of languages that the speech API supports, and how it applies to certain use cases are useful for auditing, compliance, and other use cases that we see for our media and entertainment customers. So here I'm going to switch my screen and walk through a couple of demos. Here is an application that we built where users can quickly upload audio file or a video file and have the machine learning APIs quickly perform transcription and translation and allow the users to work on these in a collaborative manner. Imagine a journalist collected information in the field and has a raw set of audio and needs to be transcribed before having the editor engaged. Today, these workflows are disjointed and requires a lot of back and forth between the various team members. So here in this system allows transcription to a variety of languages that we support. And from a user perspective, we make it very easy for a user to select an audio file and get it processed automatically. So in this example, I just selected a file and the system uploaded it into the Google storage, and under the hood it calls the Google Speech API and the natural language processing API to start deriving the results out of it. So for example, here let me select an audio file where we see the transcription and the results of it, and let me play for a few seconds to highlight a feature, and I'll add some commentary.
Artificial intelligence is transforming every industry. In manufacturing,
as you can see here, the results are provided and the users can now use the playback functionality and follow through the transcription. This is again useful for news journalists, editors to start building the news stories. Similarly, if I have a large content and I need to go to select keyword, I can just click on a specific keyword and allow the playback to start from there.
video or images of packages and extracts text in real time. If the text does not conform,
say for example, now the transcription is complete. Now I want to take advantage of the Google Drive or the collaboration. So immediately the application has an integration to Google Drive, and on just a click of a button, the Google document is available with the transcription. So now I can quickly share, include other members for collaboration, comments, feedback, etc. As I just mentioned, the same application supports other languages. Here is a quick audio feed that processed to another language. In this case, it's Hindi. If we look at the application of these type of use cases, one, in the past, the accuracy level of transcription and translation has been not up to the level for an enterprise grade deployment. Today, with the machine learning APIs that Google deployed, for example, speech to text, the accuracy level is so high, people are looking to deploy it for enterprise grade applications. These type of use cases are useful for media agencies, anyone who is generating content on a daily basis. Let me switch to another demo that highlights the use of video intelligence API and some of the custom TensorFlow models. In this demo, I am going to showcase how to process long running videos and extract insights out of it. This is a video that is around 3 hours between Roger Federer and Stan Wawrinka. And the challenge here is, can we use machine learning to generate a highlight and helps the editors to avoid looking at long running videos. If you look at a tennis game, there are certain things or points in time that are useful for editors. For example, when the referee says match point or set point, the system knows that, okay, that's the crucial point or a event in the game. Similarly, if there is a huge audience uproar, that also means that that's a crucial game point between the players. Also, from an editor standpoint, is it a long rally or is it an ace? That will also helpful from an editor standpoint. Now, if we look at it, if we process this 3-hour video and provide these interesting frames, now the job of the editor makes it easier to look for these frames and quickly start putting highlights together. Let me play a couple of snapshots and I'll add my commentary. For example, here I'm going to click a link that highlights the audience uproar.
Roger Federer is through to his 6th Australian Wawrinka.
So if you look here, these are moments in frames. The editor now has quick editorial features to start looking these frames and maybe generate a highlight out of it. Similarly, as I mentioned, when the referee says a break point or a match point is also crucial for an editor to look for.
Arrived at match points. 2 more break points.
What we have also done is we have listed the key frames for the users to understand what is there in this long running video. For example, here I want to see the frame that is ball on the line.
That's a line licker.
I want to see whether it is a long rally or a short rally. I want to see if it is a short rally here. So for example, if I select a frame, this seems to be the ace from a game standpoint. So, if we look at it, the basis is first supervised learning. We sit with this subject matter expert and identify what frames are useful to capture, and we apply machine learning and make these insights available for our users in a quick to consume fashion. If we look at it, the same concept can be applied for any type of videos from a content standpoint. What are all the frames that are of interest to me, and how can I apply machine learning to automatically look for those frames? Hopefully this is useful, gives an overview about video intelligence. Let me switch to another demo that highlights face recognition and detection. Here is a demo where we apply, in addition to video intelligence API and also vision API, find if in the frame if there is a face present, and if it is a frame that I can recognize, find some summary from, in this case, wiki page. Let me quickly walk through the pipeline and highlight or showcase the demo, and I'll play the video file. So, here is the pipeline that looks from a demo standpoint. So, we have raw video file, we process that using the video intelligence API. The video intelligence API provides coordinates and face related coordinates again from each frame standpoint, meaning if there is a face present, and coordinates and the frame details out of it. Then what we do is we pass it to the vision API and find if it is a face that we can recognize. And if we are able to recognize the face, can I get some summary details from Wikipedia? So, from a pipeline standpoint, multiple APIs are involved, and the data pipeline makes the integration here much easier, because all we are doing here is a couple of API integrations. So, let me play the video for a few seconds and I'll add some commentary later.
The Tyrrell Corporation.
Mr. Deckard, Dr. Eldon Tyrrell.
I don't get it, Tyrell.
Commerce is our goal here at Tyrrell. More human than human is our motto.
So, as you can see here, as the video plays, we are able to use the functionality of the intelligence API, split the video into multiple frames, and within the frame we are looking for faces that the system can recognize. And as you can see here, the moment a face is recognized, we are able to take a snapshot out of it, pass it through the vision API, and if it is a celebrity, we can find the details from the results that are provided from the vision API, and we are able to make a call to Wikipedia API to summarize the results. So, now again, for functionalities for customers who are looking for face detection and other location based intelligence, these type of use cases are much easier to implement with the Google Cloud ML framework as well as the APIs. Lastly, I am going to highlight demo of Vision API and how to do document processing. So, if we look at it, there are a lot of documents that are structure based, like it could be an invoice document, it could be a purchase order. There are a lot of structural documents that require human as well as other workflow based integrations to either insert it into a backend system for processing, etc. What if we can use Google Vision API and see if we can automate such processes? For example, in this demo here, let me showcase how an invoice can be automatically extract the key fields using the Vision API and say integrated to a Salesforce system. This will be useful for users and avoid hand typing or use of other OCR technologies from an external integration standpoint. So, if you look here, let me start with a template structured document. So, in this case it is a structural template, and can we use Vision API to extract some of the key fields, in this case name, address and dates, etc. From a processing standpoint, what happens here is this particular document is being processed through Vision API, and we look for entities, like say is there a name present, is there a date present, and with a combination of rules based, coordinates based and entities based, we can extract key fields easy. The same concept if I apply it to invoice document. It is a structured document. It has certain key fields that I need to look for, say for example invoice date, account numbers, invoice amount, description, etc. We follow the same pipeline process where we can pass it to the Vision API, and now the Vision API can quickly give me the results of it. Now that if I am able to extract these entities, I can integrate to my backend system, for example send this to Salesforce application. Hopefully that gives you the overview of how to process image files, video files and applying Vision for OCR type use cases. Let me switch back to my slide and cover couple of lessons learned, best practices or some of the considerations based on our recent implementations. As you can see on the top, if we were to look at machine learning for unstructured data sets, there are variety of use cases here. We can apply APIs, we can apply a new functionality that Google released called AutoML, useful for custom training models. Similarly, there are ML kits now available, makes it mobile application development much easier. Then the super developer centric TensorFlow with a large community following, where we can build and deploy custom machine learning models. In addition to it, there are also other open source tools, and community has built a lot of machine learning libraries for use and integration. So, if we look at it, there are a lot of options available. There are APIs, there are models, there are open source frameworks, etc. Some of the considerations we have seen is one, defining the user stories or requirements. This is no different from any of the other project development or implementation. Care should be taken to make sure that who the user is, what type of profile, what's the business value from an implementation standpoint, and some of the other infrastructure related use cases. For example, authentication, security, performance, how the error handling should be applied, etc. This is where SpringML can provide the right guidance and the implementation support for the enterprises. Similarly, if we look at it, data is the core element in deploying machine learning projects. So, there, and particularly in this case for media assets, data files are large. So, how do we come up with a data pipeline from an integration standpoint? Where do we store the data? How do we store the data? What type of structures that will help from an analysis of these files? Then finally, the integration. So, for example, if I have a media file, I analyze the media file, the machine learning works. Now what? How does this particular machine learning insights gets integrated to the existing business use case? Integration needs to be thought through to make sure that the insights that are derived are useful and customers can make informed decisions based on these insights. And finally, migration. How am I going to process historical data? How am I going to make sure that the past insights and the new machine learning model can coexist? The last piece is once I have the user stories defined, the business alignment is there. When I have my data side, the technology team is in alignment, how the automation piece of it. At SpringML, we joke that machine learning development is easy, but automation is super hard. So how are we going to deploy these machine learning models, automate them, and make the DevOps easier? Again, Google has come up with some of the frameworks that makes it easy. For example, for TensorFlow model development, there is a framework called Kubeflow, which uses the Kubernetes container model to make DevOps much easier. So from an implementation standpoint, we need to make sure that the user stories are defined, the data side is covered, and then the automation side of it. Hopefully that gives an insight into some of the lessons learned. Now, stay tuned for live QA. We will be back in less than a minute.
And we're back Well, thank you, Prabhu, for that presentation and demonstration. So during the demonstration, we had some folks submit some questions from the audience. So we wanted to present some questions to you. And the first one here, how long does it take to implement one of these projects? Is there an average duration? What can you tell us about that?
Sure, that's a very good question, Elias, where we get that from our customers often. There is a lot of interest on machine learning. There is a lot of hype associated with it as well. But when it comes to implementation, historically, given the complexity and the implementation duration, customers fear that it may be intensive from a resource standpoint with very minimal result from the project. So what we take through our customers is taking these projects in sprint-based, agile, incremental delivery model. We want to make sure we understand the vision of the customer. We want to make sure we understand the long-term goal and how the customer wants to derive insights out of it. Then we break it down into smaller pieces. For example, one of the things at SpringML is if we cannot show value of a machine learning project in 6 weeks, then we are not defining the question properly. So the demos and the projects that I showed during the session have most of those projects were completed in 6 to 8 weeks. That doesn't mean that I'm oversimplifying it, but at the same time, these projects doesn't have to be implemented in a traditional multi-year, multi-month implementation. So we make sure we understand the vision and come up with an implementation plan that comprises of multiple sprints and show value in each and every sprint schedule itself. So that way customers can take that insight, adopt it to the business process, let the feedback loop come in, like meaning what are the business users saying? Are they finding value in it? What are the suggestions that they are providing from the changes to the machine learning model? So we make sure that the feedback loop comes back again to the next sprint schedule and make sure the machine learning models that we built are to the customer requirements and expectations.
Thank you. Thank you. We have a couple more. An audience member said, I'm already in another cloud. Can I still use machine learning on Google Cloud?
Perfect. This is again a great question. Customers, particularly large enterprises, have a variety of deployment methods. And if we look at the Google Cloud machine learning tool sets, as I highlighted, some of the tool sets are API based that can be invoked from multiple systems. Some of the technologies are open source, for example, TensorFlow. And from a machine learning implementation standpoint, depending on the assets, there are also hardware dependency to it. For example, Google has a TPU-based framework to process large data sets, image files, etc. Google Cloud also has GPUs to process data-intensive industries. And if we look at it, that's the foundation of Kubernetes to a certain extent, where you have containers and you build your application, deploy it in Kubernetes, and depending on the platform or the cloud of choice, customer always have an option. So from our implementation standpoint, we make sure the customer gets the advantages of the Google Cloud machine learning APIs and leave the option to the infrastructure team to the deployment aspect of it.
Got it. Okay. Couple more. So what type of resources / training do I need on my team? Sounds like somebody's wondering if they have to go get a PhD. So what kind of resources training do I need on my team to do the machine learning?
Perfect. So from a project implementation standpoint, this is again, people fear that I need a PhD or I need a data scientist or I need some exceptional resources that are far and few or scarce to find. If we look at it from a machine learning project or data analytics standpoint, the need for a machine learning expertise is probably 10 to 15% of the whole project itself. So that's the core piece, a core resource needed, but it is from the larger context standpoint, it's a small slice in the implementation. If we look at it in our projects, the data integration tend to be much longer and much labor intensive than actual machine learning development itself. And as folks know, is the exercise of data cleaning, data wrangling, data processing often times is much more than actual machine learning development itself. So from a resources standpoint, some of the project related governance have to be there. So you need a strong project manager, a business analyst, a subject matter expertise that the customer knows what is that insight is. And from an implementation technology standpoint, obviously a data scientist and a data engineer are common resources. And particularly Google Cloud has done a phenomenal job on the technology information broadcasting. For example, I'm a big fan of Cloud OnAir myself, where I have learned about Kubernetes, ML kits, the new technologies that are being deployed from Google standpoint. So from the feedback perspective, resources wise, I would consider looking at from a holistic project standpoint. So as much as you need the data scientist and the data engineer, you also need to have a project manager who understands what went through from a machine learning standpoint, and also a subject matter expert business analyst who can communicate the business users to the data scientists and engineers.
Good. I thought I had to get a PhD. Good. Thank you. We have a last, seems like to be a last question. So how do you scale the processes end to end?
Yes. This is again one of the areas where probably project team or the implementation team does not see it through the end. Like as I mentioned, it oftentimes machine learning development is easy, but the operationalizing part of it is super hard. So from the processes standpoint, how do you scale end to end? So the infrastructure side of it need to be thought through, and also from the business side of it, as I said, that feedback loop is very important. Like, am I seeing value? Am I deriving the value out of it? And accordingly, make the production deployment elastic. Today, with the introduction of containers, I don't need to have a scale of processing 100 nodes all the time. You come up with a model, you deploy it. If the business users like it, if the customers are liking it, they are deriving the value, scale on a need basis. And with the Kubernetes, Kubeflow, and some of the container-based implementation, it makes it easier. So you can start small. For example, some of the projects that I showcased often has large data sets. For example, a 3-hour tennis video is quickly run into GBs. Similarly, other media companies. So if we were to set up an infrastructure on the get-go, it may look monumental. Rather, we can start small, scale, and use the Google Cloud functionalities. Most of the Google Cloud product suites, for example, App Engine, Kubernetes, allow to do elastic scaling. Make sure that infrastructure team is aware of it, and the configuration set in a way you can start small, scale based on feedback, and obviously with Google Cloud, some of the resources are infinite scale.
Right. So we built a data center already. You don't need to build another one.
Excellent.
Excellent. I think that's all for the questions that we have today. So for the folks online, please stay tuned. We have another session coming up, and it's titled 99 Problems, but GPU Ain't One. Sounds like a fun one. So again, my name is Elias and Prabhu here, and we thank you for your participation with questions. And till next time.